Okay, in this section, we're going to find the length of an arc. So we have a curve on a function, and it starts at A and stops at B, and we want to know the length of that. So using the distance formula, we could find this length if we wanted, you know, but we know that that length isn't accurate. But we know through integration, if we break this up into smaller parts, the more parts we break this up into, and then we get the distance between them, we know we would get closer and closer to the actual arc length, which is what we want to do, of course. Um, so, you know, so that's what we do. The formula for this, I could go through like how it became this, but I think you guys just want to see the formula. So that's what I'm going to do. So in terms of x, or a function of x, S is going to represent the length of an arc. Of function f. So just so you know, when we use s, that's what we're referring to. So, and a function in terms of x, it would be from a to b. It is the square root of 1 plus the derivative of f of x squared dx. And then if we happen to have a function in terms of y, it would be from c to d, 1 plus the g of y, g prime of y, squared dy, same thing. But this is the formula, and we're just going to use this formula. This will tell us any curve, anything like that. What is the derivative? Not what is the derivative? Oh my goodness. What is the length of the arc on the curve? And to do this first, we're going to do this on a straight line, because a straight line we can figure it out. So we're going to do this using an easy one first. That's all. And then after that, we'll do a more complicated one. Okay? All right, so I'm going to do a really pretty simple one. So we're going to start off with, let's do f of x equals 1/2 x plus 3. The plus doesn't even matter. But anyway, 1/2 x plus 3 from 1 to 5. So let's see here. So we're going to have at 1, and then we're going to have it again at 5, and the slope is 1/2. Oop. So we want to know that this length, this is what we're trying to find. And when we do this, when we plug in 1, we're going to have 3.5. And when we plug in 5, we're going to have 5.5. So from 3.5 to 5.5, that's an up. It went up by 2. And from 1 to 5, it went over by 4. So it went over 4 up 2. If we do a quick Pythagorean theorem, we'll get the square root of 20, which is equal to about, I just figured it out, 4.49, I think. Oh, 4.47. Okay, 4.47. Okay, so that's what we're trying to look for here. Now we're going to actually apply the formula and do this. It's not too bad. So let's see here. First off, we need f prime of x, which easily is just going to be 1/2. So let's set up our formula. The arc length from 1 to 5 would be the square root of 1 plus the derivative squared dx. So s is equal to 1 plus 1/2 squared. 1/2 squared is 1/4. 1 plus 1/4 is going to be 5/4. From 1 to 5, the square root of 5 over 4 dx. I can simplify that because the denominator is a perfect square. So I'm going to go with, and I'm going to pull it out front because it's a number. So s equals square root of 5 over 2 from 1 to 5 dx, which is actually just going to be, so the derivative of dx is just x. So we're going to have the square root of 5 over 2 x from 1 to 5. And let's actually do that. So square root of 5 over 2, x from 1 to 5. So we're going to plug in 5 for x. We're going to plug in 1 for x, and we're going to subtract them. This is going to give us square root of 5 over 2 times 4. And if you do the math there, guess what you'll get? 4.47. Okay. And we actually, if you simplify this, you could also get it to equal the square root of 20. So there's the formula. That's obviously a very simple case for you, but I wanted to start off with one very simple. Let's look at one that's not so simple. Okay, so we're going to find the interval, or excuse me, the arc length of this function on the interval from 1/2 to 2. So I already sketched it out for you in an effort to save some time. So here's our function, here's our interval, here's a quick sketch of it. So obviously this isn't a straight line, so we have to trust the formula in this case. So the first thing we have to do is get the derivative here. F prime of x would equal, if we do this, that's going to become a squared. So let's see. Times 3, that's going to reduce to 1/2. So 1/2 x squared. This is 1/2 x to the negative 1. So we're going to multiply by negative 1. And then 1/2, and then x to the negative 2. Okay, so I'm going to simplify this a little bit and make it a little bit nicer. F prime of x. I'm going to take the 1/2 out front, leaving me with x squared, and then I'm going to make this minus, and then the x negative 2 I'm going to bump back to the bottom, just like that. That's just a little bit neater for us to deal with. Okay. So let's figure this out. All right, so s is equal to, from 1/2 to 2, the square root of 1 plus 1/2 x squared minus 1 over x squared dx. Okay, so 1 plus the derivative squared dx. All right, so we're going to do some simplifying here. And actually, so we're going to square this and get a 1/4. And we're going to think of this in terms of fourth. And then we can actually put it together. And by putting that together, that's going to allow us to do some other stuff. Let me show you what I mean. So anyhow, let's see. I'm just going to focus on underneath here right now. So I'm thinking of this as 1 I'm thinking of this as 1/4 times 4 plus, that's what I'm doing with the 1, 1/4, and then x squared minus 1 over x squared squared. And I'm going to actually FOIL that out. I'm taking the 1/4 out. So square root of 1/4, and I'm going to have 4 plus, I'm going to square this. So this one squared is going to be x to the 4th. This times this, and then doubled, is going to be the middle term. So x squared times 1 over x squared, that's going to be negative 1, double it, we're going to have a negative 2. And then this squared is going to be plus 1 over x to the fourth. And then, of course, the 4 and that, we can simplify that. There's definitely some work involved here. So we're going to have x to the fourth plus 2 plus 1 over x to the fourth. And I don't know if you know this is a perfect square trinomial. And it is factorable. I'm just going to slide this up. 1/4. This is actually going to be x squared plus 1 over x squared squared. That would factor into this twice, because this is something squared, this is something squared, and this is the square of this times the square of this doubled. That's what's in the middle, because they cancel. We actually saw that as we were multiplying it out. So anyhow, now this can be square rooted. So let's get to this. Back to our integral. S equals the integral from 1/2 to 2. The square root of 1/4 is 1/2. And the square root of this quantity squared is just this quantity. So the worst part about this formula is the simplifying that you have to do before you can actually do the integral. Now this is easy. We're going to pull the 1/2 out front. We're going to integrate that, and this is the easy part. But like I said, the stuff we had to do before that was not. So S equals 1/2. The integral of x squared is 1/3 x cubed minus 1 over x. And we're going from 1/2 to 2. Anyhow, let's actually figure that out. 1/2. Let's plug in 2. So 2 cubed is 8. So 8/3 minus, so we're plugging in 2 minus 1 over 2, minus 1/2 cubed is 1/8 times 3, that's going to be 1 over 24, minus 1 over 1/2 is going to be 2. Anyhow, you do all of that, once you figure it all out, you're going to end up with 33 over 16, which of course we can round off to a number. So I'm just going to give you 2 of the starter problems on page 447, and that would be numbers 3 and 5. So just try them out, see how it goes, and like I said, let's work through them together if you are stuck at all. So if you get stuck, let's talk. All right, tune in tomorrow.